continue. All right. So I'm going to start then. It's my great pleasure to introduce Steve Vranyes. Steve is a distinguished engineer at Medtronic. He has had leadership positions in a variety of companies prior to his position at Medtronic, including CTO at Veritas. And given the fact that we're already a little past the top of the hour, I think without further ado, I will pass it over to Steve, who's got a really interesting talk lined up today. So Steve, welcome.
Thank you. Thank you. Yeah, so very glad to be able to be here and part of the Red Talk series at UW-Madison. I recently joined Medtronic about 3 years ago. As was shared that I come from Veritas as CTO, and decided to jump into the medical device space. Really seeing the power of software and the opportunity that it has to really shape people's lives. And so doing that, at Medtronic has been just a really great opportunity. It's the largest medical device maker in the world. It has an awful lot of resources to be able to draw from, and it has an incredibly compelling purpose and mission. And so with that, I want to jump into the content for today. And the first thing is that mission of Medtronic. When you work with technology all the time, and you think about, really hard problems in engineering, whether it's in, mechanical or electrical or software or whatever it is, there's an awful lot of things that you can focus on, and it's really, easy to get focused very deep into the technology. But the really thing that was compelling for me in joining Medtronic is, as I mentioned, that mission of every day knowing that no matter how frustrating the day might be, no matter, what technology you're working with may have, delighted you or disappointed you, that you walk home or you go home at the end of the day, knowing that you've done effort, you've created, work that has really brought the mission forward of alleviating pain and restoring health and extending life for somebody very specific, somebody whose, grandmother you may know, or maybe your own parent or even a child. And that to me is what makes these things that we'll talk about today so interesting, is that while it's deep in technology and looks at a lot of the things that, the problems that have been solved and are yet to be solved, that the application of these things is really doing a lot to make people's lives better every day. So with that, what I wanted to start off with is just going back a little bit in history and thinking about change and thinking about, the world of software technology and how it's evolved over the years, because it's really important when you look back to help figure out how things are going to, proceed in the future. So when I look back at 1990, so this is the year that I graduated from college and began to work at Motorola down in Chicago. And one of the things that's been kind of a hallmark of my career for this entire time is driving change in a lot of different ways in each of the companies that I've worked at. And at that time, back in 90, you had an awful lot of things that were changing, but it was limited. So it wasn't everything changing under you kind of at the same time. Unix was becoming a much bigger thing, and networking was becoming a big thing as well, creating applications in that were able to talk together over distributed systems. Before that, there had been some things, but this is when networking and distributed applications became a much bigger deal. And this, by the way, was before the dawn of the internet. This is before Mosaic as a browser came out, and the internet became much more pervasive. We had to wait till 1993 for that to happen. You had user interfaces that were changing as well, where, for example, when I joined the group at Motorola, it was a curses-based user interface. So you had a keyboard, and moving up and down, left, right was kind of the extent of how graphical in that you got. With the advent of the Mac and X Windows in the open source or the Unix space, things began to become much richer in terms of what we were able to do. And then the languages were evolving as well, where, when I started, it was, C as the dominant language, and probably not even ANSI C if I remember correctly at that time. And along came C++. So there was change, right? And it was important change, but the change was escalating. The change was really kind of beginning to build and snowball. And then, you move the calendar a little bit forward, then you get to the year 2011, where there's this idea that software is eating the world. A quote from, rather famous quote from Mark Andreessen. So Mark was talking about just, if you look at what software is capable of doing, it's capable of doing things in really different ways and really compelling ways that go beyond what you'd been able to do in hardware in the past. I mean, hardware's there; it's really important. So, don't take me wrong on that. But software kind of has a unique, set of capabilities that are, capable of doing even more interesting things that, are a level of magnitude beyond that. And then you take the calendar forward a little bit more in the year 2020. And it turns out that, Mr. Andreessen was right. Software is eating the world. And you have an awful lot of innovation now in the technologies and that you use to develop your applications, the environments that you develop them in. And when I look at that, you think about, well, why is that? If you look at, across the way that you do development, pretty much everything is changing. The databases, the way you do development, where you host your applications and your functionality, that's all changing. And what you see is, probably the biggest thing that happened in that time frame from, certainly 1990 and probably, 2000 to 2020 was pervasive connectivity. It was the fact that you could really connect from, one place to another much more simply than you could before. So you had, IP as a protocol and the ability to connect, businesses and that around the world, and then even into the homes where you begin to, see things like, cable modems and that with internet connectivity. You had Wi-Fi and you had your phones beginning to, take on, connected capabilities. So that was really important. Just, connectivity to pretty much anything, anywhere. And by the way, that continues to evolve pretty rapidly as well. When you look at some of the things that are happening now with, technologies like Skylink, constellation of satellites that is supposed to give you 100 megabit service pretty much anywhere in the world, that changes things. You have Facebook, I believe, doing a fiber optic cable around, the continent of Africa. So these things continue to evolve and things are only going to get more connected. You then look at open source as a major driver in these things. So if you look at the dominant technologies on the right, there are some that are proprietary, but there's an awful lot there that is actually based upon open source technologies. And even actually when you go into the cloud, Amazon's got proprietary tech and Microsoft does as well. But a lot of what you see running in there is based upon open source as well. For example, Microsoft apparently runs more Linux in their cloud than they do Windows in their cloud. So if you look at this, then you say, man, a small amount of change in 1990 where things, okay, they're changing, and now it's like everything is really being kind of rocked. This really takes you to kind of a new place, and the question is why? What are the drivers for that? What is it that has caused all this innovation to happen? Why have people spent their time, their money, their energies, and that creating some really interesting and powerful technologies? And at the end of the day, it's really not just the technology itself, but it's about the problems in that allows you to be able to solve. So, thinking back to the comment about connectivity, like, okay, I can connect from anything to anywhere. Now, well, because I have all that connectivity, I can now, create applications on that connect to so much more than they were before. That creates an awful lot of scale requirements. I need to be able to go and, scale to, petabytes of information. I need to be able to connect to, 1 million, 10 million, or 1 billion things that are out there. And I can, because the base connectivity that is there. But that why is what drove an awful lot of the other innovation that happened. So it was Google going off and, indexing the web essentially, that created, a drive to do things like, clustered database, technologies, and, many more things as well. Yet also other problems that had to be solved. So how can I, manage the volume of and variety of data that exists when I connect all this stuff? In the medical device space, there's this notion of your personal digital twin, but there's really even a digital twin for other things. So other companies will talk about a digital twin for your factory, a digital twin for your car. But when you do that and you create this digital twin, which creates a lot of opportunity to be able to understand and analyze and get to better outcomes, there's an awful lot of data that comes with that. So the telemetry and that coming off these things is generating a huge volume of data. In a world in which this, works, because of the, the power of this technology, there's also a fair amount of need for the security and privacy around that. So how do you ensure that? You have things, more things that are being touched, you're connecting to more of what's out there in the world, that also creates a certain, increased attack vector for, that you have to protect against in regard to security. You have privacy concerns as well with the data that's being captured. So in Europe, you have GDPR. So there's certain requirements that, get imposed upon your data that you've captured when you're doing business there. In California, you have the the Privacy Act there as well, which is bringing similar needs to GDPR, even in the United States. So that introduces yet kind of another dimension of complexity. But the data in that is one thing. That's important to capture it. It's important to manage it well, to be able to ensure you're compliant with various laws and that are in place. But the data itself doesn't really get to the outcome. You need to be able to analyze that data in new and more interesting ways to be able to actually understand what's going on in that environment. If I have a digital twin for my car or my factory or for myself, how do I drive insight from that? How can I tell if I'm about to become sick? How can I tell if my factory is about to experience some downtime? So it used to be that, when you would go and collect this data and that, you could go and you could answer these questions, some, time down the road. Maybe there's a, a quarterly or weekly report that gets generated. But now with the ability to derive insight, you need to be able to do these things in near real time in a way that is comprehensive in terms of its perspective. The comprehensiveness gives you, a more complete picture and allows you to be able to get to, better insights. How can you move more quickly? So if you're building software in that and it takes you forever to release this stuff, how can you, change that? How can you actually get, functionality out to the market in a way that is faster? So in the medical device space, one of the things you think about, kind of pointing back to that Medtronic mission is, the longer it takes you to be able to go and innovate and do these things and release kind of with the quality in that you need, the longer somebody is waiting. And you don't want that, right? That waiting time means time when somebody is not, being alleviated from their pain, when they're not, being restored to health in the way that is possible with the, innovation that you bring into the market. And then lastly is just this notion of platforms. So it used to be when you'd think about innovation, the innovation was generally limited to the capabilities that you would have within the boundaries of a company. So you have a company and, you have a certain set of resources, a certain set of funding, a certain set of capital, intellectual property and such, and you take that to market. But that's kind of limiting in terms of the, the problems that you're trying to solve in that are actually bigger than the four walls of that company. So how can you do things in a way where you can actually bring other people to the problem in a way to create more interesting, more complete, more, compelling solutions for your patients in the case of, medical devices, but in other spaces as well. And so this last bullet really kind of speaks to the power of platforms. So platforms have become, a really big thing. They've been around for a long time in various forms. So if you look at the car industry, you can think about platforms there, right? So they'll, a particular car manufacturer, whether it's, Toyota or GM or whatever, has a hardware platform. But software, going back to one of the things I think makes it even more compelling, has kind of a different notion of platform, which is the ability to not only reuse your designs or your implementation of things, which is what you get in a hardware platform, it also allows you to be able to bring things together in ways that solve problems. So for example, a platform like Uber brings, people together in terms of people who can provide transportation and people who need to go someplace. So that's kind of a two-sided market. But there can be even more sides to the market, and that same model can be applied to other domains as well. In the case of Medtronic, into healthcare in particular. So platforms become, a really important thing that the technologies we saw on the last slide are important for helping solve. So where does this take us? You can ask. Say, okay, a lot of technology, a lot of logos on that, and you can see that that's really not going to change. That speed of innovation and the evolution of software isn't going to change in the near future. But one of the things I would say is the things in recent years in software have really changed so much that I think it's actually fair to talk about it as next gen software, or software 2.0, as Andre Karpathy has called it. Now, Andre is actually calling it software 2.0 because of the introduction of AI into that last slide. But there's really even more there that's happening. Just kind of the whole move to cloud native computing and what's required of your software when you want to be able to scale to massive levels. When you want to be able to deal with a lot more data than you had been able to do traditionally in the past. Really, there's new programming models on that are required in order to be able to tap into those technologies in a way that really unlocks the value that they were built for. So whether you call it next-gen software or software 2.0, as I mentioned, the rules have really changed, and the way of developing within those environments has changed. But with that, I want to put just that on hold for a second here and get more into, back into the medical device space. So, and we'll draw that line, back to software 2.0 in a second here. So if you look at Medtronic in the cardiac space, so Medtronic was founded based upon the idea of portable pacemakers. Earl Bakken, way back when, created the first first pacemaker, and really began kind of a whole new market and a whole new way of thinking about how you bring benefit to patients. And over the years, that ecosystem and that has really evolved. So as you can see on the left side, you have this modern day pacemaker. And you think about that, okay, that's a device that's very important to the people who have that. It keeps them alive in a lot of cases, and helps them to live healthy and better lives. But that's just the one device. It's the thing that gets the most attention, but there's really this other ecosystem around it that's required in order to really be able to deliver better outcomes to patients, right? So when that device gets implanted into a patient, there's a certain programming that has to occur to give them a optimal, outcome with that device. There's a lot of different parameters in that can be set. When they go and they, go into a clinic, the person following up with them in the clinic, they want to be able to do things like interrogate that pacemaker, see how things are working, and perhaps change some of the parameters that were set when it was first implanted. And so you have kind of a whole clinical ecosystem. For the patient as well, they have an ecosystem that they work in, or they kind of experience this care in. So you see that on the top where you've got the pacemaker, and that's a device that's implanted probably for in many cases 12, 13, 15 years, something like that. So the battery drain in that device is a really critical thing that engineers work with all the time in terms of how to get the most out of that, how to make it so that the device can last for its longest life while providing that therapy. And to be able to do that, then you need other things to complement that, because that device doesn't have the power to be able to go and send data directly to, to the cloud. That takes a fair amount of energy to be able to go and do that. So there's other things that have been created in that ecosystem, like a mobile app that can talk to the device. There's bedside monitors that can talk to the device. And those things then have the power to be able to send that data up and into the cloud. And into the cloud, where it can be, displayed to the right people, to the clinician who is following up with the patient to make sure that they are, everything is going well according to plan, and make adjustments when that's needed. So that's the ecosystem as we get into the next slide that we work in. Like I said, very much, a lot of focus on the device, the pacemaker or ICD, but really an awful lot of ecosystem that has to happen around it to really get to the outcome that is best for the patient. So one of the things that has happened over the years in Medtronic is that we've really thought about platforms and kind of the, for the ecosystem that delivers that care. So the reason we think about that is because, there's a lot of innovation that happens in the devices, new devices come along, and we need a way to be able to bring those into that ecosystem in a way that is as seamless as possible, where you don't have to go rewrite everything because some new, capability exists that didn't exist yesterday in one of these devices. So we need a way to be able to plug that in into the ecosystem, benefit from all the value the ecosystem creates, but then also reveal the things that are unique to that device. So that's where you get to these platforms that we've been building over time, and that we continue to invest in. And the one I want to talk about the most here next is the MLife Core platform. So the term data mesh was in the title of this talk, and so we finally get to that slide. And one of the things that we really try to focus on in the way that we manage data in that is a high degree of flexibility and capability when it comes to managing data. And what I'm trying to put out here in this talk is the idea that, in the past, you would think of putting that data into, maybe a traditional relational database, or you put it into a data lake and you try to, extract value out of it in that way. And what I'm seeing in terms of the evolution of all those, technologies that you saw, a few slides back, is the opportunity to do something different with that data, and to do things different in a way that really helps to unlock a lot more flexibility and capability in the way that you manage, that data and gain that insight. So this idea of a data mesh, like I said, it's different than the concept of a data lake, in the sense that instead of like one big lake, the idea is to have actually multiple data storage technologies, or you could think of them as ponds if you want to continue the kind of the lake metaphor. So instead of one lake, big lake, you've got ponds, and then an important part, actually very critical part to the idea of a mesh, is the fact that you've got streams that are capable of moving data between ponds. So we can actually start out with data that's perhaps in one database, like in this diagram, maybe it starts out in, I don't know, the SQL database. And then I want to be able to do something additional with that. So going back to kind of the Medtronic, scenario of, hey, I want to be able to create a more complete picture of that patient. Well, I might actually want to be able to draw on data from multiple sources. So I might have some of that data about the patients in a SQL database. Some of it's perhaps in an object store or a memory database. And now, because I know the clinician's about to look at this data, I actually want to go and, create a composite view for this that is ready for that clinician when they want to see that, patient. So how do I do that, right? I need this flexibility in data in order to be able to do these things. So it's the idea that, the core of the mesh is the fact that I've got ponds, not one big lake. I have streams that allow me to be able to move data flexibly between them. But if you look back at the why, think back to the why slide, one of the things we also said is it's really critical to be able to manage this data well, and to be able to ensure that you have the security and you have the proper governance around that data. So then you bring into the mesh some other concepts like a data catalog. So one of the ideas, one of the things that, I think has been seen to be true for a long time is that a data catalog, or if you want to manage anything, the first thing of managing, first principle of managing that is to have visibility. And that's actually what a data catalog then allows you to do. It allows you to say, okay, for this data mesh, where are the things, where's the data in this environment? How can I discover that? How can I, then go and bring that together in new ways? And then especially, where's the stuff that is PII or PHI data? You then need a policy capability, which then allows you to say, okay, I understand the catalog, I understand what I have. Now I need to be able to put policy around that. Who should be able to access this data? If I have a researcher who wants to be able to access the data, about patients because, they're developing the next algorithm or they're developing kind of the next device, or maybe, the FDA needs it because they want to understand, certain things about these devices and that. Putting policy, around that data becomes kind of a critical thing. And then in the mesh, probably the big thing is I want to be able to plug in the microservices and that allow me to do things with that data, to transform the data or to, serve up new, kind of usage scenarios for the patient or clinician or whoever it is. Some microservices plug very nicely and neatly into this kind of architecture. And then last is, we're going to talk a bit more about this, is the foundation for AI is really based upon a really tight game in your data, in data governance. A lot of times we think about things that are really interesting in AI in terms of new ways of training your models or new algorithms or whatever it is. But if you don't have it, if you don't have the information, you're not really able to do much there. So when I look at the top technical reasons for the mesh, this is kind of where I got to in terms of what to me is kind of most compelling about that. So the first idea is that, a mesh in that will scale very, very well, right? Because part of that mesh can be, very proven, very scalable database technologies. So you have technologies like, HBase or Cassandra, like with HBase in particular, I know, some people are using this in the 40 petabyte range. So it can handle a massive amount of data. And they can scale even just with one database, and they can scale obviously further with multiple. I have a very capable data foundation that is necessary in AI. Just mentioned that, and we're going to talk more about that in the following slide. And then I have a way of, to add streaming as a new style of interface in the platform. So I spent a fair amount of time in that, the why slide on platforms. And this is kind of the big thing is that, in the past, platforms have been very focused on the APIs, very focused on, really the API defined the platform. So I think about platforms that I've worked with in the past, like VMware is a really good example. You had certain, areas of capability, of APIs in that platform for storage and networking and compute and that kind of thing, and allowed you to be able to interact with it and to be able to plug new things into it in some pretty, compelling ways. But what I'd put out there is just this idea that, it had been the API and it'll continue to be the API, but the data streaming or data mesh kind of concepts actually have an opportunity to open up, I think, some new and more interesting doors for what a platform can be. A mesh also does, number 4 here, architectural evolvability. I can do really, interesting things quickly. And that's important because in the past I had, you might have thought you knew all the requirements for your architecture at the beginning, and you'd go through this waterfall development model, you try to figure out everything, come up with the ultimate design and then implement it. That notion is really kind of being, left behind. Where software architects and that are doing more now to evolve, to essentially create an architecture that allows you to be able to evolve in the future and then do things, like, plugging in the next, set of technology, the next database and that comes along. Part of that evolution of software is also, hit on a number 5 where you have teams in that are going off and implementing new functionality, but they want to be able to use in that kind of the best-in-class code, the best-in-class tools and technologies in that. So it also becomes important to give them options, because it's not just one team with this kind of dictatorial, this is the way it's going to be, and it's going to be only this way. Giving latitude in that to teams becomes a really good way to, one, make them happier, which is important, but also really to drive innovation that allows them to think more broadly about what they're going to bring to bear on the problems that they're trying to solve. So this also then fits well with architectural practices. So if you look at, microservices and everything that's going on there, a data mesh fits very well with that, where I can plug in, new services that are very independent. I can change them, evolve them asynchronously, and really kind of turn the crank, as I like to say, on software and keep the pace of innovation or the incremental movement of your software platforms moving forward, at a steady rate. You can fit well into existing environments. So in the data mesh, you can go and say, okay, you might have some, almost certainly there are other data sources that already exist in wherever you're doing, kind of application development. So how do I go and, I can tap into those things as well. I can improve my ability to snap in, which I kind of already, touched on in new technology. So if you look at, and this is one of the interesting things, if you look at, the innovation that's happening in networking and storage and compute and that, the databases and the technologies you've seen have been really incredible to see, the rate of innovation, but this is not slowing down anytime soon. Memory technologies like 3D XPoint, or, the continual evolution of GPUs, TPUs, CPUs, really is going to, I think, continue to drive more and more disruption in, this space. Actually, I'll, the rest you can read here. I'll kind of move on for the sake of time. The one important point on AI is what I want to hit on here, which is there's an awful lot that's going on kind of in the AI space in terms of new frameworks and new ways of doing inferencing faster or whatever it is. But really, AI has the need for fuel, and the fuel is data. And the goal of really kind of most companies is to have kind of a really strong position in that data so they can do AI and they can get into this virtuous loop. If I have data and I manage it well, I can get to better algorithms. If I have better algorithms, then that's going to drive better outcomes for customers, which will drive more data, and then the loop goes on and on. And there's a tremendous amount of truth to that. But one of the things that gets missed, though, is the machine learning that people will tend to focus on is this little red box in the middle here. When if you look at what's really necessary, it's like the red box could be kind of a pilot in a plane, and then there's an awful lot of other stuff that has to happen for that plane to fly and that pilot to do its thing. You need a ground crew, you need somebody to handle baggage or fuel or cater the plane or whatever it is. So the ability to have kind of a very strong foundation for data management, to be very flexible and nimble with the way that you're dealing with data, becomes a really important part of enabling AI. I think companies that are in a really good position regarding their information foundations are going to be ones that are better suited or better situated to to really do well with AI. So the question then is like, okay, that's interesting. Is that utopia? Is that, is the data mesh it? Have I gotten to nirvana with that? And the answer to that is clearly no, right? So for anything that you do, there's definitely some downsides, and that's where I want to put some, kind of thinking out there for you guys to, to really, kind of ponder or, discuss or whatever going forward. Because I think there's an awful lot of really interesting problems here to be solved. And I think you guys are probably in a really good place to take some of these things on. So if I, to really take it down to the things that I think are probably the two most, challenging things to creating, being very effective with the data mesh, I'd say, number one is by far just the increased complexity for developers in dealing with data. And a lot of this actually comes in really not just because it's of the data mesh, but really the the idea of microservices as a cloud architecture concept, or way of, not so much a concept, but it's just as a way of delivering functionality. Microservices get a lot of buzz. There's a lot of talk about them, but the data management aspects of them is actually not for the faint of heart. Let's just say that. And we're going to talk more about both these in the next slide here. But then number two is the increased infrastructure and complexity. Now, this one's number two. It's important to call it out, but this one I feel that we have some ways of dealing with. And so most of the call out here is going to be around number one. So how do we do this? How do we deal with some of this complexity that a data mesh brings on? So one of the things we look at is, one, go slow. So anytime you bring, you're bringing in new technology, new ways of doing things, what you have to do, especially, with a decent size, organization and, an important capability that you're delivering, is to not just go big into everything. How do you kind of start small, get some learning, get some, things going under your feet, build a certain capability that gives you the confidence and learnings to be able to go further in the future. Another thing we're looking at doing is, really focusing on changing kind of the developer mindset. So in the past, you would have thought about kind of, services and databases. So whether it's a REST-based, service, microservice in a database, whatever, there's another important concept that people really have to think about, which is thinking in terms of streams of data and kind of the flow of that data between, different repositories. And the fact that when you do that, you have to be a bit disciplined and think about, hey, you don't want to have the ponds that we talked about earlier, anybody going and writing to, any one of these and thinking it's the authoritative copy. There's got to be, one of those copies has got, probably got to be the one that you write to, and the others are going to be ones that you read from and consume from these other database technologies that are serving up in some new, cool, powerful way. You need to, have developers think about designing and coding for independence and immutability. These are not things that, a lot of developers are really familiar with. And there's things that have to be kind of thought about and learned and really become kind of second nature for, developing that next, microservice that you want to be able to put out there. Thinking in terms of what can be eventually consistent. So this is one of the things where, cloud computing, people will think about, eventual consistency. Well, we'll just do that. That works in some situations, but it doesn't in others. So where is the proper application of that, and where do you need to perhaps keep things more in a relational database with ACID properties? And then adding design patterns is probably one of the bigger ones. So if you go and look at microservices and how do people deal with the kind of data issues in that of a microservice, there's patterns like a saga pattern or a command pattern that get talked about. These are important patterns. And then creating common runtime environments as well to really simplify things. Like how can I take as much complexity off the table as I can and create more of a consistent environment for the developer to be able to work in. And that's not an easy road, number one. And we're going to talk about some of the challenges here in the following slide. Number two, I'm much more comfortable with, which is there are some additional services that you're talking about standing up. You have things like Kafka or any additional database that you want to be able to use. There's a fair amount happening there that takes that complexity and makes it quite a bit simpler. Just consuming some of these things as paths or beginning to deploy things like DevOps, which you probably need to be doing anyway for a variety of other reasons. These are things that really can take, number two here of the complexity and really ratchet it down to, very manageable levels. But number one is still a problem because if you think about this, with number one, I feel like, yeah, we can do this and we're going to start slow and we're going to learn in that. But I still feel like we're, kind of working on a dirt road where things are just a bit slower. You can't go quite so fast and that to me is a problem, and obviously a problem is an opportunity. I think that there's an opportunity here to really get to a much better way of dealing with this kind of computing where you've got AI and you've got this data mesh, because you've got these platforms that you're looking to be able to do more with, especially with data. So this is the opportunity that I see, And what I'm hoping is that, perhaps some of you, listening to this will take on some of these challenges and think about, okay, is that, first of all, do you believe that in terms of a data mesh and its power? And then, what are the things that you might be able to do to take on some of those limitations? And what do you have to think about at the end of the day is, as cool as, all the latest algorithms in that are, and this technology can be, in order for it to be adopted, in order for it to really go mainstream and kind of have the impact that you're probably hoping it'll have, it has to be, accessible by most developers. So it can't require kind of a PhD in, some deep theoretical area. You've got to make it so that, more people have, the ability to go and leverage it successfully. You can be put out there, but if you can't get to the position of, hiding the complexity and reducing the cognitive load, as I like to say, on the developer, because they want to be thinking about the things they're getting, paid for in terms of solving problems for the patient. They can't be taking on, a very complex environment in order to be able to do it, even if it brings all these other benefits that we went through. That's nice, but it still has to be approachable. It still has to be usable. And then how can, so when I think about that, then I think about, well, how can problems be avoided in the first place? So we have things like design patterns and that we've used in the past. We talked about, the saga pattern, command pattern, and there's other patterns as well. So that's one way of approaching it, but that has its limits. Are there ideas, that could be, explored in the area of language support for doing some of these things? That's another avenue or, potential vector to go down to be able to solve some of these problems and unlock kind of the power of a data mesh. Other libraries, services, and code generation or frameworks that can be looked at. One of the things that what I look at is when I think about something like, how we got to where we are now, somebody actually went off and, created Paxos and Raft as algorithms. That was really powerful, right? And then they got codified, right? It became possible to use those, algorithms and that in your own cluster. So things like Yarn and that became, a thing. So is there opportunity for, is that a potential avenue to solve some of these problems? Other tools or IDEs that, could be leveraged to solve these problems or modeling. So all, kind of a class of, class of possibilities or avenues that could be looked at to go and solve the problems that, a data mesh, and really, it's not even just a data mesh, it's really, problems inherent in a microservices architecture. How can we make that better? And then, failing that, what are things that could be done to make it so that problems in these environments can be detected? So if I get into situations in that where, I'm going to, risk a data corruption, or I'm going to risk, inconsistent data or whatever, how do I detect these scenarios and then recover from them? So all these, I think, are things that need to be looked at, and, progress needs to be made on in order for microservices and really a data mesh to be able to move forward and have, the full impact of what's possible. Because at the end of the day, I just want to bring it back to the mission. So when I think about these problems and solving them, it goes back to this, to this mission. And one of the things I just want to call out is I visited UW-Madison a while ago, and I looked at the admission form or application. And one of the things that was on there, and I'm guessing it's probably still on there, was there was a question which is how will you fully leverage all the resources in that the university makes available to advance your education and advance really kind of the cost for which you're working. And so that's a really rough remembrance of that. But it was, I loved it though, because it really spoke to the, man, if you fall in love with the problem, if you fall in love with, the problem that you're trying to solve, and not in love with just the tool or just the first idea or, or the process or whatever it is, then you begin to become really resourceful in terms of, bringing everything you can to bear to solve that problem. And in this case, creating more powerful technologies and approaches to solving these problems. And when I think about Medtronic, we're actually trying to do a very similar thing here. So, you know, when we think about the capabilities that exist across the company, we have a cardiovascular group and we do certain things with pacemakers and ICDs and that. But how can we then also draw on other resources of Medtronic? Like we have a company that was acquired a while ago called Neutrino, which does AI for food. You know, how can we use kind of a data mesh approach or something like that to bring those capabilities into the problem space and then solve problems for for patients and that in a way that is more complete, more compelling, leads them to better lives and less pain in their daily lives. So I love your thinking that Madison has in that space. We're trying to apply that same thinking in Medtronic, and actually our new CEO Jeff Martha has very clearly kind of called this out in his first months as CEO. So if we can solve some of these problems in this space in terms of creating things that are data mesh like or data mesh itself, I think it puts us in a much better place to solve problems that are more difficult to solve than without that, where data can play kind of a more important, more prominent role. And I think kind of the case for the importance of data in doing that is, I think, been made. But I'll leave that out there for questions or comments. And then last, I have to put this slide in because these, because I spent a lot of time on talent. Because no matter how much technology you have, no matter how much process you have, no matter how much culture you have, talent is absolutely critical. And so one of the things we're continuing to do is building the talent base that we have in the organization. And this top bullet or top URL is the jobs that we have open now. There's not a ton there, but there's definitely some. But there's also, quite a bit more that's about to be there in the near future in cloud development, working on the technologies that I mentioned and bringing them together in the way that I mentioned. So we're looking for, people who have kind of a passion for the mission itself of Medtronic, but then also have a passion for these technologies and the application of them. And then last, if you're interested, please feel free to reach out to me. This is my, Medtronic email. And happy to answer questions or help you find anything you might be looking for at Medtronic. And so with that, I will end the talk here. Thank you.
Thanks, Steve. Lots of virtual applause. That's always one of the hardest things to manage virtually. So even though we're kind of up against the hour, we started a little bit late. So I think it'd be great if we could keep you around for a couple minutes past the top to answer some questions.
Sure.
I see one hand raised, and I'm going to, instead of doing this in the Q&A, I think it'll be quicker just to unmute people. Students, if you or attendees, if you want to ask questions, just raise your hand. And I'm going to unmute Dhaval Shah. Okay, thanks.
Yeah,
yeah. Please go ahead.
Hello, can you hear me?
Yes.
Yeah, I can.
Yeah, thank you very much for this. And Steve, the question I had is that so you are in Medtronic, right? And you do the diagrams for the data mesh and other things. So where do you draw the line between what someone in Medtronic would do to fix these issues versus what you would look for from another company, like a software company? You know what I mean? Like, because looks like you sort of know all this so well. So how much would you just take it on inside Medtronic and how much outside Medtronic?
Yeah, so that's a really good question in the sense that there, in terms of like who goes and works on these problems, there is well, let me say it this way. So with the importance of software, I think clearly increasing, the organization has really kind of put a priority around that and really making sure that we have, an excellent team in terms of skill sets all around, whether it's, data science and AI or cloud or, embedded development or whatever it is. So we do try to have, the kind of the critical capabilities, well-staffed internally. We also understand that no matter how much hiring you do, no matter how good you are, there are other really smart people outside, and we want to be able to tap into that as well. So Medtronic does do a lot of partnerships with different universities on a number of different problems in different areas, and that I think actually is going to tick up a bit. Actually, I think we have kind of a well, I know we have one with UW-Madison. I think it's new to be able to partner with you guys there, and then we also look. We're also looking at how do we especially with the platform, be able to bring other, startups into the picture. So Medtronic actually has a venture capital arm, and they'll go invest in startups. They also buy, obviously, as I mentioned earlier, a number of those startups. And then maybe the last area, maybe this is where you're thinking about, is in terms of, like consulting organizations that we work with, we definitely tap into that as well. There's a number of, firms that we've worked with that have deep specializations in some of these areas. And we'll continue to do that. But one of the things we do know is, because of that criticality of software, while we tap into all these different areas, we also want to have kind of a strong home base or foundation of capabilities in-house.
Other questions by attendees? Steve, I've actually got, I've got a long list of questions, but I'm not going to keep you for too long. But one that's really sort of top of mind, which is that I find your description of the data mesh compelling on several levels. And while I can see the opportunity and power that it brings, I can also see a number of issues that are potentially more difficult in the environment that you described, one of them being security. Yeah. So, I mean, if you have these different systems, that are connected together, you have to have a really robust security model in order to, assure your data in this environment. So I wonder if you could just take a minute or two and talk about the approach to security in a data mesh.
Yeah, no, that's a really good question. And the answer to that actually very much kind of lies with the just dealing with complexity in general. And so one of the things that was really clear is we took this on, this creating of this platform. We took it on because we were dealing with, just a really large amount of data that was proving challenging for the existing system to keep up with. We saw that, just continuing to increase. So we said, okay, we need this new technology. Many of the technologies ahead on the previous slide. And as we said that, we said, okay, you can't just bring in that technology. There's complexity there that causes you to say, okay, we need to build this in a different way as well. The old techniques of building weren't going to work anymore. So we made a really big investment in DevOps, and in terms of at least the cloud assets, and actually extend even beyond the cloud, there's also this notion of DevSecOps, which is the really a strong focus on four things, I'll say. One is repeatability, testability, and observability. And the fourth one that is really important in DevOps also is culture. But I'll talk about the first three as it relates to security. So that's to say that if I can make everything as code and have a high degree of automation, I can now have things that are very repeatable. And if you look at a lot of the security lapses that have happened in the past, it's actually been kind of fat fingering or just kind of human mistakes that have entered into the picture. So the repeatability helps me with that. The observability then is also super important. It's the fact that as things are happening in the system and that there is, a high degree of understanding of what's going on, and then essentially monitoring these things using, kind of your latest tools. One of the things I think is really powerful there as well is because you've done that, because you put in this observability, there's a lot of other tools that are now coming into place in what's called, I think AI ops is the right term, where AI is being applied to in the security space to be able to detect things that are not normal, things that are anomalous behavior or fraudulent activity or whatever. So that's, I think, in terms of the security of this, kind of the most critical thing that we're doing. And fortunately, it's kind of the same thing that is helping us just deal with the complexity itself. When we actually talked to our security group and we talked about DevOps and everything as code and putting this in place, observability and that as well, they loved it. They absolutely loved it. One of the guys on the team who shared that with them became, they became his biggest fan, because these practices and that are essential, and they put security, or our global security office, in a much better place where, instead of just seeing a presentation on here's kind of the architecture we're going to put in place, you can actually see the code. You can see what's going on with the logs and that. So you get to kind of a much better position. So very long answer to your question, but hopefully answers it.
Well, I think you've definitely opened my eyes to the idea of DevSec AI ops. I don't think I've ever sort of seen a string quite that long, but I like it.
Okay. Yeah, if you look it up, you'll actually see DevSecOps rather than DevSec AI ops. AIOps is another thing that gets lumped together.
Okay, but maybe I was coming up with something new then. All right.
There you go.
Well, listen, Steve, thanks so much for your time today. Really enjoyed the talk. Students, please feel free to reach out to Steve or to take advantage of the jobs pointer here on this last slide. So with a final thank you for taking the time today. I really appreciate it, and we'll look forward to being in communication with you on an ongoing basis, Steve.
All right, thank you.
Okay.
It was a pleasure. Thanks for the opportunity.
Yeah, I'm going to stop recording. Okay.